Hi everyone, my name is George Lee. For our project, my main responsibility was designing the object-oriented backend, the game engine class, which handles the core scoring logic and game mechanics. To give you a quick overview of how our game works, FAQ is a play with 6 dice. On each turn, a player rolls a dice and must set aside at least one scoring die. Based on the standard rules, a single one is worth 100 points, and a single five is worth 50 points. Three of a kind also scores. For example, 1 are worth 1,000 points, and 3 of any other number is 100 times that face value. After keeping scoring dice, the player faces a strategic choice: either roll the remaining dice again to risk getting more points, or simply bank their turn score. But be aware, if you roll and get zero scoring dice, that is a fail, and you lose all points earning during that turn. The goal is to be the first player to reach our target score. And to implement these rules digitally without cluttering our UI, I encapsulate everything inside the game engine class. For the rolling mechanic, the engine uses MATLAB built-in ready function to calculate exactly how many active dice the player has left and only generates new random numbers for those specific dice. If a player successfully scores with all 6 dice, the engine resets the count to 6, allows them to keep rolling under the horse dice rule. The most compact part of the engine is the calculator algorithm. To analyze the dice effectively, I use MATLAB hit function to tally the frequency of each dice phase. The algorithm first checks for special condition like a 1, 2, 6 threat. If not, it loops through the array. If it detects 3 or more of a kind, it calculates the base score and applies a dynamic base 2 multiplier for 4, 5, or 6 of a kind. Finally, it catch and add up any remaining single 1 and 5. And finally, the engine acts as a reference. After every roll, it evaluates the dice. If the score is 0, it triggers a fail, wipes the turn score, and passes the turn. If the player checks bank, the engine simply updates the total score and checks against the winning condition. And by separating the logic from the app designer UI, we achieve a very clean and professional structure. And now I want to pass it on to next member to talk about the visual and multiplier.
Hi, my name is Zihao Liu, and I'm in charge of making the user interface and app designer. So, as you can see on the left side, we have 6 area for dice. When I click roll dice, it'll play some animation and sound effect for the rolling dice. So I have now 6 different dice. I can click whichever one I want to keep, and click the score kept dice, and this will be gone and record it as a move. In the log table, you can see here. Now I get 100 point for one dice. If I click bank point, it'll just move to the next player. If I click it, and then I can switch to player two, which we can do on the other PC. Like when I click roll dice, it'll be player two. And if we want to get a new game, we just click this button, then this log table will be gone. And if we click the sync remote state, it'll just sync the game state from the ThinkSpeak because we upload our every move to ThinkSpeak. So if we click this button, it'll automatically extract the value, the data from ThinkSpeak and think it to our current game status. And beneath it, we have the text area, which will show some error messages and some hints for the game. And here's four area for the game status, current turn, turn score, player one total, and player two total. And we have one more checkbox here. If you check this box, that means you are doing a remote game, so you can play this game on two PCs. By checking this box, you need to type in your channel ID, read key, and write key in order to connect your MATLAB to the ThinkSpeak. And you can select which player you want to be, player one or player two here. And in my startup function, I already initialized this value to be my channel in ThinkSpeak. So when you click run in App Designer, it'll automatically be my channel IDs and keys. Now I'm going to introduce the code in App Designer. So for the properties, I have 4 properties, which is engine, selected dice, log data, awaiting score selection. The first property engine stores the game logic object, and the second one, the selected dice, tracks which dice the player has clicked. The third one log data stores the history shown in the table, and the last one, the waiting score selection, prevents the player from rolling again before scoring the current roll. For the functions, the first function I use is refresh dice selection. This function updates 6 dice buttons on the screen. It gets the current active dice from the game engine, removes button text, and displays the correct dice image using icons. It also changes the background color in order to highlight the dice that the player has selected. If a die is no longer active, the icon is cleared. And the second function I have here is play sound file. It's right over here. I use a function called audio read to read the file from here, which is the file name. In this use a try and catch block so that if the file cannot be read, the program does not crash and instead shows the error message in the message area. And the third function I have here is update score labels. This function updates the text labels that shows the current turn score, and the total score for player 1 and player 2. And the next function I have is local player number. This function checks the dropdown and returns whether this app instance is currently acting as player 1 or player 2. And the next function I have is remote configured. And this function checks whether remote play has been properly set up. It verifies that the remote checkbox is enabled, the channel ID is valid, and both read and write key are filled in. And the next function I have is push remote state. This function basically sends current game states to ThinkSpeak. It packages information like current player, current score, run score, etc. to ThinkSpeak. The next function I have is pull remote state, and this function extracts the latest saved game status from ThinkSpeak. It reads the most recent feed, convert it into a snapshot using the game engine, which we have in our file, imports it into the current app, clears the selected dice, refreshes the dice display, updates the labels, and shows the latest action message. And the next function I have, let me see, is get dice icon. So for this function, it builds the file path for the for the dice image corresponding to a die value, such as dice1 .png file to dice6, so that I can that's how I correspond a number to a image. Like if I have one as the output for a dice, and this output will correspond to a image file, which is the dice1.png file, so that it can make sure it shows a PNG file, not a number. So the next function I have is this function here, this animation for dice roll. So this function creates a rolling animation before the final dice value are decided. It briefly shows I think it's 3 random dice picture for a few steps, and after the animation, the final roll was decided to for the gameplay. I think by doing so, I think this makes the interface more realistic and looks better. And next, I'll explain all of the callback functions. The first one, I have the startup function, which is I initialize some value like here. I initialize the turn score label text to be 0, player 1, total to be 0, player 2 be 0, etc. Just initializing those values. So for the roll button pushed, this button runs when the player click roll dice. It first check whether the remote mode is on to make sure it is the correct player's turn. Then you check whether the player still needs to score the current hand before rolling again. If the roll is allowed, you place the dice animation, calls the game engine to roll the dice, and checks whether the result is a Farco. And at the very end, you can see I play a sound here. The sound file is the sound effect for rolling dice. Now I have the six callback function for each of the dice, so that you can shows the dice images and the dice value, so that we can function the game. Next, I have the score button pushed. The score button pushed runs when the player clicks score kept the dice. It checks whether it is the correct player's turn in remote mode and gets the currently active dice, finds which dice the player selected, and sends those indices to game engine. If the move is valid, it updates the game states, refreshes the display, updates the score, show a message, locks to move, and pushes the remote state, which is uploading the current data to the ThinkSpeak. The next callback I have is bank button pushed. For the bank button pushed, this button runs when the player clicks bank points. It checks the ownership of the turn in remote mode, cause the engine to bank the turn score, updates the display as it add a bank action to the log and sync remotely if needed. And the next callback I have is new game button pushed. This button resets the game. It clears all of the engine state, select the dice, lock table, and etc. It's just like restart the game and reset the game. The next function I have is sync button pushed. This function just simply call the function pull remote state, which lets the user download the latest game state from ThinkSpeak so that they can synchronize its value and all of the data with the other PC. I think that's all I have to say for the.
Okay, hi everyone, I'm Yufei Wang, and I was responsible for implementing the game state class, which manages the current state of the game, including dice values, scores, playing turns, and the game ending condition. Okay, so first, in the properties section, I define the variable that stores the game state. The dice values stores the values of the dice after each roll, and it initializes as a 1/6 array because the game starts with the 6 dices. And the turn score records the points accumulated during the current turn. These two variables stores the total score for player 1 and player 2. And the current player indicates whose turn is it. The value of 1 means player 1, and the value of 2 means the player 2. The target score defines the score needed to win the game, which is 5,000. And dice remaining tracks how many dice are still available to roll during the current turn. Then finally, the game over shows whether the game has ended, and the winner records which player wins. Okay, next, in the method section, I define the function that update the game state as the game progresses. The first function is a reset game. This function resets all variables back to their initial values, so the game can start from the beginning. The roll dice function simulates the rolling dice. First, it checks whether the game is already over. If the game has ended, it returns immediately without rolling. Then it reads the number of remaining dice from dice remaining. This line shows the MATLAB's randy function to generate random integer from 1 to 6, which represents the dice values. Then the function clears the previous values and stores the new roll in the dice values array. The next function is applying scoring result, which updates the game state after scoring happens. This line adds the points gained to the current term score. This line. And this line reduces the number of the remaining dice based on how many dice were used for scoring. If all dice are used for scoring, the dice remaining becomes 0. In that case, it resets to 6, which follows the standard hot dice rule in Farkle. The Farkle function handles the case where the player rolls but gets no scoring combination. In this case, this turn score is resets to 0. The remaining dice resets to 6, and the dice values are cleared. Then the game switches to the other player. The bank function is used when the player decides to save the points from the current turn. If the current player is player 1, the function adds turn score to the player 1's total score. Then it checks whether player 1 has reached the target score, which is 5,000. If so, the game is marked as over, and the winner is recorded. The else branches does the same thing for player 2. If no one has won yet, the function resets the turn state and switches to the next player. Finally, the switch player function alternates turn between player 1 and player 2. It utilizes a MATLAB switch statement. If the current player is player 1, it changes to player 2. Then, in case 2, if the current player is player 2, then it changes to player 1. So overall, the class manages the main state transitions of the game, including rolling dice, updating scores, handling Farkle, banking points, switching turns, and determining the winner. That's it. Thank you.